Let us try to understand how do we apply the concept of antiderivatives to find the integrals. Basically, we need to rearrange the equations. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand how do we use antiderivatives to find indefinite integrals. Well, the concept is simple. If the derivative of the function is f of x, then integral of that derivative should be the function itself plus a constant, right? Since we get the family of curves, we'll have the same derivative. We'll look into this concept before getting into the solution of these 4 questions also. So here are 4 questions for you which are based on antiderivative concept. The question is, if y equals to 5x minus 3 to the power of 10, then find integral of 5x minus 3 to the power of 9 dx. If y equals to 2x square root x, then find integral of square root of x dx. If y equals to square root of 1 minus 6x, then find the integral of 2 over square root of 1 minus 6x when integrated over x. If y equals to ln x square plus 3x minus 7, then find the integral of 4x plus 6 over x square plus 3x minus 7 dx. Now let's first review the concepts learned. So what we saw earlier is that if we have a function, let us say x cubed, let's say y equals to x cubed. In that case, what is dy dx? Well, dy dx of x cubed will be 3x squared. But if y is equal to, let us say, x cubed plus some constant k, in that case, dy dx will be what? It will be 3x squared plus 0. That means, again, 3x squared. Now see, k could belong to any real number. And what we see, that the derivative is losing that constant. And the reason is very simple, that d dx of k is 0. As illustrated with the diagram, if we take the function where k is 0, then it will go through the origin. But if k is not 0, it could be one of the other graphs. However, the derivative is same, and which is 3x squared. Now what is integration? Integration of 3x squared should give us the function back, right? So therefore, we see that the integration of 3x squared should equal to x cubed plus a constant which we write c. Is that clear to you? And that is what indefinite integral is all about. We get a family of curves instead of exact function. Clear? So let's get to the definition, and that is, if the derivative df of dx is equals to f of x, then we call this as a differential equation. The given equation contains a function and their differential. It is called differential equation. So this is a differential equation. To solve a differential equation, df dx equals to f of x, is to find an expression for f, the original function, right, as a function of x. That really means to undo the differentiation by means of inverse operation called integration. So, integration is the inverse operation of differentiation. So, df dx equals to f of x implies that f, the original function, should be integral of f of x dx. You get the idea. To explain it in words, here the operation of integration is denoted by the symbol. So this symbol is the operation of integration as a whole. the function f of x to be integrated is placed between the integral sign, that S-shaped elongated is the integral sign, and differential dx, that's an operator. So integrate over x, that is what it means. Integrate with respect to x, correct? So integrate with respect to x is dx. So it's just an operator. This function f of x itself is called an integrand. So f of x is called integrand. This is integral sign, right? Basically, it is s which is elongated. Do you see that? Stretched s. Summation. So we'll see that part. So I hope this concept is now clear to you. With that, now let us see how do we find the antiderivatives to actually get the integration done. So the very first question was, if y equals to 5x minus 3 to the power of 10, then find integral of 5x minus 3 to the power of 9. So we are given that if y is equal to 5x minus 3 to the power of 10, right? Then we have to find the integral of 5x minus 3 to the power of 9. This is what we need to find. Now to find this, we'll actually differentiate this part and see what do we get after differentiating the given function y. So we get dy dx as equal to 10 times 5x minus 3 to the power of 9, correct? Times the derivative of inside function, which is 5, correct? So we get this as equal to 50 times 5x minus 3 to the power of 9. Is that clear to you? So that really means that the integral of 50 times that given function is that. Do you understand? Correct? So to get the same thing here, what is missing? Let's try to connect these two, right? Let's try to connect these two. So what we see here, that 50 is extra here. So I could add and I could multiply and divide by 50, right? So I could write this integral on the right hand side now as equal to what? I could write this integral as 50 over 50, right? Times 5x minus 3 to the power of 9 dx. I kept this integral same. Multiplying by 50 over 50 really means that we are multiplying by 1. So we are not changing the function, right? So that means now we have something which is exactly similar to what we differentiated, right? This part. Do you see that? Do you see that? So now we could clearly write this as taking out that 1 over 50 outside the integral sign, we have 50 times 5x minus 3 to the power of 9 dx. Correct? And we know what is the integral of this portion. Well, the integral of this portion is y, which is 5x minus 3 to the power of 10, right? So we get our answer, and the answer now is 1 over 50 5x minus 3 to the power of 10, and we have to add a constant c. You get the idea. So that is how we are going to use derivatives to find the integral, and we call this process as antiderivative. So I hope the concept is clear, right? So let's get back to the definition. So if the derivative is given to you as f of x, then the integral of derivative is the function itself plus c. Do you see how we connect them? That is how you have to do these questions, correct? So have a good look at it. So basically what we did here is kind of simple. Let me just summarize once again for you. We found that y is equals to 5x minus 3 to the power of 10. So we said dy dx is equal to 10 times 5 times 5x minus 3, right? So that became actually 50 times 5x minus 3. We wanted to figure out what is the value of the integral of 5x minus 3 to the power of 9 dx, right? Sorry, this was to the power of 9, right? So I hope this, concept is absolutely clear, right? Now, let us take the second example. So the second example before us is y equals to 2x square root of x, right? You will always write this as 2x to the power of 1 plus half, which is 3 by 2, right? And therefore, the derivative dy dx is equal to what? 2 times 3 by 2 x to the power of 3 by 2 minus 1, which is half, right? Or square root. So you can write this as 3 square root of x. So that is the derivative, and therefore we know from here very clearly that the integral of 3 square root x dx is equal to what? Is equals to the original function, right, plus c, correct? That is what is known to us. Is that clear to you? Now, what do we need to figure out? Well, the question here is to find the integral for square root dx, right? So let's do that part. So we need to find what is the integral of square root of x dx. Now we know that 3 times square root of x dx is that, right? So what we'll do here is that we'll write this as equal to integral of, we can multiply and divide by 3, right? So we can say 3 times, that means 3 over 3 of square root of x dx, correct? Now this is same as 1/3 of integral of 3 times square root of x dx, correct? Now we'll compare. We know that this integral is that much, correct? So we know what is the value of integral of this. So using that, we know this is 1/3 of 2x square root of x plus c. Makes sense? So 2/3 of this, right? So we have our answer, which is 2 over 3 x square root of x plus c as the integral of square root x dx. Is that clear to you? Perfect. So let's take another example to illustrate and get practice. Now let's take up question number 3, which is y equals to square root of 1 minus 6x. Then find the integral of 2 over square root of 1 minus 6x dx. Since we are given y, let's find the derivative dy dx. So the derivative of this will be 1 over 2, and this will be 1 over square root of 1 minus 6x, right? Half, and derivative of inside function, which is minus 6, correct? So we could simplify this as minus 3 over 2 times square root of 1 minus 6x in the denominator. Is that clear to you? So that is what we get. Now, so that clearly means that the integral of this is the given function, right? It means that the integral of minus 3 over 2 times 1 over square root of 1 minus 6x dx is equal to 1 minus 6x, the original function, plus a constant c. Is that clear to you? So that is given to us now. So that's the understanding. If you find the derivative, then inverse of the derivative is constant plus the function integral, right? Now we need to figure out what is the integral of 2 over square root of 1 minus 6x. This strategy is you have to get the same expression as you know the integral of. So we have minus 3 by 2 here, and here we have 2. So to get to minus 3 by 2, what should we do, right? This is what we have to think about. So what we can do here is that we can multiply and divide by minus 3 by 2, right? We can multiply and divide by minus 3 by 2. So let us do that. So we can write this as equivalent to, let me write down, minus 3 by 2 times 2 by minus 3. Does it make sense? So now we are multiplying by just 1. Is that clear to you? And we already have the integral, which is 2 over square root of 1 minus 6x dx. Did you see that, operator? So the idea here is, since we know minus 3 by 2 times 1 over square root 1 minus 6x dx is 1 minus 6x dx plus c, so we did this operation. So now I will take this minus 3 by 2 inside, right? So and bring the other 2 outside. So we get 4, 2 times 2, right, is 4. Or let me write like this. That 2 I am bringing outside. This 2 I am bringing outside, right? And I am keeping 2 over minus 3. You get the idea? And within the integral, I am writing minus 3 by 2. I took that inside times what remains is square root of 1 minus 6x dx. Does make sense to you? So we transpose, just rearrange the numbers. The idea is to get this function inside. Correct? So we have matched this function. Do you see that? And therefore, we can now write down our answer, which is, simplify this, minus 4 over 3, correct? And the integral is square root of 1 minus 6x plus c. Do you see how we have done it? Rearrange the equation so that you can match the integrals. Perfect? That is the strategy. Let's take up the last question now. So here we are given y as equals to ln x square plus 3x minus 7. So what is dy dx? Dy dx is 1 over all this, which is x square plus 3x minus 7 times integral of this, which is 2x plus 3, correct? So we have 2x plus 3 in the numerator over x square plus 3x minus 7. So we know that derivative for a function we know, and so we know its integral should be that, right? So I'm not writing this time. On the other hand, we have to find the integral of 4x plus 6 over x square plus 3x minus 7 dx. Now, how are they related? Well, I think 2 is a common factor which could help us relate them exactly. So we could write this as integral of 2 times 2x plus 3 over x square plus 3x minus 7 dx, right? Now that gives you the answer, 2 times, because we have perfectly matched all this, right? Do you see that? So our answer now is 2 times the function itself, which is ln x square plus 3x minus 7 plus a constant c, and that is the indefinite integral solution which we see on the board. Is that clear to you? Perfect. So that is how we are going to use this particular definition and find the integrals. Perfect. So I hope all the concepts are absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. You can always contact us on the email address given for more information. Now, in the next video, we are going to consider how do we find integrals using the rules, right? So we'll get into the rules and take up more examples. I hope the series is helpful to you. Feel free to share with me your comments. Thank you.